Welcome to Study Loop.
So here we have the three cases. Let's say this is A, this is B, and this is C. So these are the cliffs, and let us see the heights are same. So these are the three cliffs, and in a ball is thrown horizontally. In B, a ball is thrown at some angle to this, and in the third situation, let's say a ball is thrown like this with some angle theta. So assume that they are thrown with the same initial speeds. Okay, only the angle of projection is quite different over here. And if we observe that all these three kinds of projections, they are projected from the same height. So if we consider the initial potential energy, so that initial potential energy will be same. So for initial potential energy in A, it will be same as B, it will be same as C. And if we talk about the initial kinetic energy as well, that also will be relatively same because they are projected with the same speed, and kinetic energy just depends upon the speed. Okay, and initial potential energy, that depends upon the height. Of course it depends upon mass and acceleration due to gravity, but these are all constants in these cases. And if we talk about the time when they meet, or when they hit the ground, so at the time they hit the ground, at that point of time they will be having certain speeds as well. So at the time of hitting the ground. So at the time of hitting the ground, if we talk about the kinetic energies, in order to determine kinetic energies, let us just analyze it a bit. So in the first case, the ball is projected here, and let's say the height it has to come down is h. So if we consider the motion along x and the motion along y, so along y the motion will be almost same in terms of displacement. So displacement is h. So let us consider this first case. Displacement is minus h, acceleration is minus g, and initial velocity along y is 0. So from here we can find out the speed along y. So we'll use 2as is equal to v squared minus u squared. So we get minus 2 into minus h into minus g is equal to v squared. So v will come out to be root 2gh. V will come out to be root 2gh. And along x, initial velocity is v, acceleration is 0, and to find out final velocity, since there is no acceleration, so final velocity will be same. So it will be v only, right? So we have got final velocity along x, and we have got the final velocity along this y. So in this case, if we figure out the velocities or the speed with which it hits the ground, that will be root of this v square plus this square, so 2gh. So this will be the speed for the first one. Similarly, if we try to get for the second one, we can only see that for the second one all other things remain same, only this initial velocity changes. So it will be v sine theta, and here the initial velocity will be v cos theta. So finally also it will be same because there is no acceleration. And in the second case, that is vb, it will be root of v cos theta whole squared plus the speed along y direction. So that speed will be, we can obtain that speed using 2as is equal to v squared minus u squared. So that will be 2gh is equal to v squared minus u squared will be v squared sine squared theta. So this will be v in the b case. So this vb will be 2gh plus v squared sine squared theta. So here we will square and add them. So what we are observing in this situation is that as the angle of projection is increasing, the speed with which it hits the ground is increasing. That means in this case, if we talk about the speed with which it hits the ground, it is greater in B, greater in A, and the least in C. So in this case, the kinetic energy, of course, it's going to depend on the square of these speeds. So kinetic energy will be greater in B than A than C. And finally, if we talk about the time of flight in each cases, so that time of flight is dependent on the displacement and initial velocity. So let us just look at an expression of time of flight. So from any height, let us say if a ball is thrown at an angle theta and from height h, so here we consider motion along y, and here the displacement is minus h, initial velocity is v sine theta, and final velocity we do not have any idea. Acceleration we have minus g, so we first find out v. 2as is equal to v squared minus u squared. So that will be 2gh is equal to, this will be v squared, let's say this is v dash square, so final velocity, minus v squared sine squared theta. So final velocity we get idea from here. To find out the time, what we will do, we'll use s is equal to ut plus half at square. So we use minus h is equal to v sine theta into t minus g by 2 t square. So from here we can get the idea that time of flight will be greatest in that case which has more vertical component of velocity in the positive direction. So this is having more velocity in the positive direction. So time of flight will be greatest in B and it will be least in C. So this is also going to follow the same trend.